Did you know that there are tests being conducted utilizing UAP on mental patients and entire small towns in Arizona? In 2023 it's called Cybernetics Research by DF Light and Nova. There can be various purposes or objectives for conducting a cybernetic program in a small town. Here are a few possible reasons. 1. Testing and validation. Conducting a cybernetic program in a small town can serve as a controlled environment to test and validate the effectiveness, feasibility, and impact of cybernetic systems or technologies. The smaller scale allows for easier monitoring and evaluation of the system's performance and outcomes. 2. Research and innovation. A small town can provide a unique setting for researchers to explore the sociological, economic, and environmental impacts of cybernetics. It can generate valuable data and insights on human-machine interactions, social dynamics, and the benefits or challenges associated with implementing cybernetic systems in real-world contexts. 3. Community engagement and empowerment. Involving a small town in a cybernetic program can foster community engagement, collaboration, and empowerment. It allows residents to actively participate in decision-making processes, co-design solutions, and shape the development and implementation of technology in their community. 4. Sustainable development. Cybernetic programs in small towns can focus on sustainable development objectives. This might involve optimizing energy usage, improving transportation systems, enhancing resource management, or creating smart infrastructure solutions that benefit both the environment and the local community. 5. Economic growth and innovation ecosystems. Implementing cybernetic programs can attract investment, promote entrepreneurship, and stimulate economic growth within a small town. It can create opportunities for startups, technology companies, or research institutions to collaborate, innovate, and develop new products or services based on the cybernetic infrastructure. Ultimately, the purpose of conducting a cybernetic program in a small town can vary depending on the specific goals, priorities, and needs of the community and the researchers involved. Putting a town under the influence of cybernetics is a complex and multifaceted process that would require careful planning, implementation, and integration of various components. The time it would take to execute such a program can vary significantly depending on factors such as the scale of the town, the specific objectives of the cybernetic influence, available resources, and the complexity of the technology being deployed. Generally speaking, the implementation of a comprehensive cybernetic system in a town would likely require an extended period of time. This could involve several phases, including research and development, infrastructure setup, system testing, community engagement, and gradual deployment. The timeline could span anywhere from a few months to several years. It is crucial to note that any implementation of cybernetics should be conducted with careful consideration of ethical implications, privacy concerns, and community consent. Engaging with stakeholders, conducting feasibility studies, and obtaining necessary approvals and permits would likely add to the overall timeline. It is important to emphasize that the hypothetical scenario of putting an entire town under the influence of cybernetics raises significant ethical concerns and would require extensive planning, collaboration, and oversight to ensure responsible and respectful implementation. The end result of a sociological experiment involving cybernetics would depend on the specific objectives and design of the study. However, some potential outcomes or insights that could arise from such an experiment include: 1. Understanding human-machine interaction. By studying the interactions between humans and cybernetic systems, the experiment could provide insights into how people adapt, perceive, and collaborate with technology. This understanding of human-machine interaction can inform the design of future technologies and improve user experiences. 2. Identifying social and behavioral patterns. The experiment may uncover new social patterns, behavior changes, or emerging norms within the community as a result of the cybernetic influence. This can shed light on how technology impacts social dynamics, group behavior, and collective decision-making processes. 3. Assessing impact on community well-being. The experiment may evaluate the impact of cybernetics on the well-being and quality of life of individuals within the community. This could involve measuring factors like satisfaction, happiness, connectivity, or access to services to understand how the technology affects various aspects of community life. 4. Evaluating ethical and societal implications. The experiment would likely prompt discussions and evaluations of the ethical considerations and societal implications of implementing cybernetics in a community setting. The findings can contribute to the development of guidelines, policies, or regulations to ensure responsible and ethical implementation of similar technologies in the future. 5. Informing policy and decision-making. The results of the sociological experiment can be used to inform policy decisions regarding the integration of cybernetics in society. Policymakers can draw upon the findings to make informed choices regarding the deployment of technology, ethical guidelines, and potential benefits and risks associated with cybernetic systems. Ultimately, the end result of a sociological experiment involving cybernetics would provide valuable insights into the social, psychological, and societal impacts of these technologies. It can shape future research, guide the development of ethical frameworks, and inform the responsible and beneficial integration of cybernetics in society. Yes, it is possible to conduct cybernetic research without the use of biotechnology or biohacking. Cybernetics is a multidisciplinary field that encompasses the study of control systems, communication between humans and machines, and the interaction of information and feedback loops. Here are a few areas of cybernetic research that do not involve biotechnology or biohacking. 1. Human-machine interfaces. The development and improvement of interfaces between humans and machines are a significant focus in cybernetic research. This may involve studying and enhancing technologies such as virtual reality, augmented reality, brain-computer interfaces, haptic feedback systems, or gesture recognition. 2. Robotics and automation. Research in robotics and automation focuses on the design, control, and application of robotic systems. This includes areas like industrial automation, autonomous vehicles, intelligent robotics, and the integration of robotics in various domains to improve efficiency, safety, and productivity. 3. Artificial intelligence and machine learning. Research in artificial intelligence, AI, and machine learning, ML, explores the development and application of algorithms and models that allow machines to learn, reason, and make decisions. This can involve studying neural networks, deep learning, natural language processing, computer vision, and other AI/ML techniques. 4. Sensors and Internet of Things, IoT. Investigating the use of sensors, data collection, and the Internet of Things, IoT, can be central to cybernetic research. This includes deploying and analyzing sensor networks, exploring data aggregation and analysis techniques, and developing systems that use IoT devices to enable efficient monitoring, control, and communication. 5. Cybernetic systems and control theory. Research in cybernetic systems and control theory involves understanding the principles of information flow, feedback loops, and system dynamics. This field explores the design and analysis of complex systems, control algorithms, stability, optimization, and adaptive control mechanisms. These are just a few examples of cybernetic research areas that do not involve biotechnology or biohacking. Cybernetics is a wide-ranging field, and there are numerous other avenues of exploration and study that focus on the interaction and control of non-biological systems. For a cybernetics program on a larger scale, such as in a small town or city, various hardware components and technologies may be useful. Here are some examples. 1. Sensor networks. Deploying a network of sensors throughout the town or city can provide real-time data that is essential for monitoring and feedback in a cybernetic system. These sensors can include environmental sensors, surveillance cameras, motion detectors, or even wearable devices to gather information about individuals' behaviors and interactions. 2. Communication infrastructure. A robust communication infrastructure is necessary to facilitate the exchange of information between different cybernetic components. This can involve wired or wireless networks, including broadband internet connections, to ensure seamless and reliable data transmission. 3. Actuators and robotics. In some instances, cybernetic systems may involve physical manipulation of the environment. Actuators, such as motors or robotic arms, can be utilized to initiate actions or respond to feedback based on the cybernetic control system. 4. Computing resources. Large-scale cybernetics programs require substantial computing power and resources for data storage, processing, and analysis. This may involve utilizing powerful servers, cloud computing platforms, or distributed computing architectures to handle the computational requirements of the system. 5. Control mechanisms. To manage and regulate the cybernetic system, control mechanisms are essential. These can include centralized control systems, algorithms, or artificial intelligence programs that monitor and make decisions based on the feedback received from the sensors and actuators. 6. User interfaces. Depending on the nature of the cybernetic program, user interfaces can be crucial for human interaction and control. These interfaces could be in the form of displays, interactive dashboards, or mobile applications that allow users to monitor and interact with the system. It's important to note that the specific hardware requirements for a cybernetics program would depend on the objectives, scale, and complexity of the system being implemented in the town or city. The selection of hardware should always align with ethical considerations, privacy concerns, and respect for individual rights and autonomy. It's important to note that conducting experiments that involve influencing an entire town or population would raise ethical concerns and require careful consideration, approvals, and oversight from relevant authorities and ethical review boards. However, I can provide general examples of research that can take place during sociological experiments involving cybernetics. 1. Human-machine interaction. Researchers may investigate how individuals in a town interact with cybernetic systems or technologies. This can include studying the acceptance, adaptation, and impact of these technologies on social behavior, communication patterns, and decision-making processes. 2. Behavioral observations. Researchers might observe and analyze how cybernetics affects social dynamics within a town. This can involve collecting data on changes in group behavior, social norms, or the emergence of new social structures as a result of the cybernetic influence. 3. Survey and interview studies. Research can be conducted through surveys or interviews to understand the perceptions, attitudes, and experiences of individuals within the town regarding the cybernetic systems. These studies can provide insights into the social and psychological effects of cybernetic influences on different aspects of life. 4. Data analysis and visualization. Researchers may analyze large-scale data sets generated by cybernetic systems within the town to identify patterns, trends, or correlations. Visualization techniques can be employed to communicate the findings in a meaningful and understandable manner. 5. Ethical and societal implications. Sociological experiments involving cybernetics necessitate exploration of the ethical implications and societal impacts of these technologies. Researchers may engage in discussions regarding privacy concerns, social equity, power dynamics, and the potential consequences of the cybernetic influence on vulnerable populations. It's crucial to approach research involving cybernetics and sociological experiments with responsible and ethical considerations, ensuring the well-being, privacy, and autonomy of individuals within the town. A cybernetics program typically involves the study and application of cybernetic systems, which encompass the interaction of humans, machines, and information processing. While the specific activities and outcomes of a cybernetics program can vary depending on the objectives and focus areas, here are a few examples of what can happen during such programs. 1. Research and development. Cybernetics programs often involve extensive research and development efforts to advance the understanding and application of cybernetic principles. This may include studying human-machine interfaces, artificial intelligence, robotics, neural networks, and other related areas. 2. Experimental design. Researchers may design and conduct experiments to explore the behavior of cybernetic systems. This could involve creating simulations, running controlled studies, or building prototypes to test the effectiveness and efficiency of different cybernetic concepts or technologies. 3. Data analysis and modeling. The collection and analysis of data play a crucial role in cybernetics programs. Researchers often use statistical analysis and modeling techniques to identify patterns, make predictions, and gain insights into the behavior and performance of cybernetic systems. 4. System integration and implementation. Successful cybernetics programs involve the practical application of the research findings. This can include integrating cybernetic systems into real-world scenarios, developing prototypes, or implementing solutions that enhance human-machine interaction in various fields such as healthcare, manufacturing, transportation, or communication. 5. Ethical considerations. Given the potential impact of cybernetics on society, discussions related to ethics, privacy, and safety are essential components of cybernetics programs. Ethical frameworks and guidelines are often developed to address the responsible design, use, and governance of cybernetic systems. These examples provide a broad overview of what can occur during a cybernetics program, but it's important to note that the specific activities and outcomes can vary significantly depending on the scope, objectives, and individual research projects within the program. There are several companies involved in the field of cybernetics and related technologies. Some well-known companies that are engaged in research and development in the field of cybernetics include 1. Boston Dynamics 2. Neuralink 3. OpenAI 4. iRobot Corporation 5. Cyberdyne Incorporated 6. IBM Research 7. Mitsubishi Electric Research Laboratories 8. Google, Alphabet Incorporated, 9. Lockheed Martin 10. Honda Research Institute. Please note that this is not an exhaustive list, and there might be other companies that are also involved in cybernetics research and development. It's advisable to further explore each company's specific areas of focus and expertise. Here are some general resources and organizations in northern Arizona that you can consider reaching out to for information or connections related to various fields and research. 1. Northern Arizona University, NO, a comprehensive university located in Flagstaff, is with various research departments and centers. They may have resources related to cybernetics or can provide guidance on local research initiatives. 2. Northern Arizona Center for Entrepreneurship and Technology, NACET, an incubator and accelerator supporting innovative startups and technology-based businesses in northern Arizona. They may have information on local tech companies and research initiatives. 3. Coconino Community College, CCC, a community college in Flagstaff that may have resources or connections related to research and technology programs in the region. 4. Flagstaff STEM City, a community initiative in Flagstaff focused on promoting and supporting science, technology, engineering, and mathematics, STEM, education and career opportunities. They may have information on local STEM-related initiatives or networks. 5. Flagstaff Chamber of Commerce, they can provide information on local businesses, economic development, and may have connections to relevant technology organizations or research programs. Remember to reach out to these organizations to inquire about specific resources, research initiatives, or contacts related to cybernetics. They may be able to provide further guidance and connect you with the right individuals.
Certainly. In the heart of Central America, archaeologists uncovered a remarkable archaeological site that brought together the rich cultures of the Aztec and Maya civilizations. Hidden within ancient Mayan tombs, they made an astonishing discovery, an Aztec mummy adorned with an intricately etched artifact of Egyptian origin. The expedition began with the exploration of an untouched Mayan burial ground located deep within the dense jungles of Mexico. As the team carefully excavated the site, they uncovered a series of elaborately decorated tombs, each holding the remains of ancient Mayan nobles. Amidst the grandeur of these tombs, they came across an enigmatic burial chamber overflowing with artifacts and treasures. At the center of this chamber lay a remarkably preserved Aztec mummy, covered in intricately woven textiles and adorned with jade jewelry. What astounded the team, however, was a small, exquisitely detailed artifact clasped within the mummy's hand. Upon closer examination, they noticed the unmistakable hieroglyphics reminiscent of ancient Egyptian symbols etched into the surface. This remarkable fusion of Aztec and Egyptian influences sparked theories and speculations among the archaeological community. How did an Egyptian artifact find its way into a Mayan tomb, along with an Aztec mummy? The artifact itself added to the mystery. It depicted a scene of remarkable cultural synthesis, an intertwining of Mayan, Aztec,